fallacy number 8, and the last of the 8 fallacies of distributed computing. The network is homogeneous. Now, clearly today we're in an environment that is much more, has many more moving parts and technologies and platforms than ever before. But I want to take you back a bit, roughly 10 years-ish. That was sort of the height of consolidation in our industry. .NET and Java largely ruled most of the enterprise. Most of the interop between .NET and Java was already resolved. And for the most part, you could go into an environment knowing that the different beats are really going to be able to talk to each other. And we could focus more on the business problem side of things than making sure that all of the different technologies talk to each other. Unfortunately, since then, there's been a period of decentralization. As many of the thought leadership that used to exist in Java moved on, and then we got Ruby and NoSQL, and there's this stuff called REST you might have heard of. REST is colloquially called something I hacked together over HTTP that might or might not work with something that you hacked together over HTTP. So the whole idea that everybody speaks HTTP is sort of, it underplays the reality of what is done in the name of REST. So, for example, what serialization model are you using on top of HTTP? Well, clearly everybody uses JSON. Have you ever had a problem where your JSON serializer wouldn't speak to somebody else's JSON serializer? Yes, hands are going up around that. But everything's JSON. It should just work out of the box, right? Then there's NoSQL. NoSQL is a fancy way of saying none of your reporting systems will actually work on top of this data model. So you're going to have to reinvent all of the reporting in order to support this NoSQL. Isn't it great that MongoDB is web scale and all that kind of stuff? So I don't want to paint too grim a picture, but the silver lining is that it's going to be a good 5 or 10 years more of decentralization that's happening. You mentioned Elixir and Erlang, and it's kind of the old is being reinvented as the new, and all of this stuff, it's making its way into more and more systems. We have a good 5 or 10 more years of creating bigger and bigger, more distributed technological messes before somebody's going to say, okay, this is just insane, and we need to do some standardization. And then it'll take another 20 years from that point until we get back to where we were in 2005. So good news is job security for everybody. All right? If you're in IT, there will be need for custom software and integration between all of these pieces for the foreseeable 30, 40 years. So until we retire, we're sorted out. The generation behind us, well, the quantum computing will solve everything at that point in time, and AI, and yada, yada, yada. So it's going to get worse technologically before it gets better. I mentioned the clouds before. What's so great about the clouds? AWS and Azure, all of their services are incompatible with each other, so you actually have to custom build something if you want to move it from one cloud to the next. Google obviously has its cloud, and there are a whole bunch of other IBM clouds and Dell EMC clouds and whatnot, and there's the Open Cloud Initiative. Anytime you hear the word open, that's a clear indication will not interoperate with anything outside of this initiative. All right? It's open, so it can interoperate with anything, which means it doesn't out of the box. All right? Some other words about integration for those of you in various industries. There have been a couple of initiatives that have been sort of vertical industry specific to solve more business integration problems. I think, did anybody mention insurance? Anybody in insurance? I heard mortgages. I think that. So in there's the Accord standard for structuring data. I don't think I ever heard healthcare. There's HL7. In retail, there's GS1. In HR, there's HRXML. Every industry has their own standard. And the great thing about every standard that's been created is there's a certain area that's been left for extensibility, which is a fancy way of saying that anybody who needs to do something that's a little bit different from the standard, which is everybody, is going to pile on into that section of the protocol that isn't fixed. Which is why one HL7 message is not compatible with another one, and one GS1 message is not compatible with another one, and why you have different versions of these specs that aren't compatible with each other. So even if you're in an industry that has these type of standards, the good news is there will still be integration work for years to come. All right? It's not ever going away. But on top of all of that, I want to talk about this thing I call semantic interoperability, which ultimately talks about the business semantics. What does the data mean, and how do those elements of meaning translate across boundaries? So let me illustrate this point with a very simple example. It was a healthcare project where we had a system for an emergency room that needed to accept patients that were coming in, and we had another system that dealt with actually the medication, prescribing the medication and all that kind of stuff. And we needed to pass a patient object from the ER system to the medication system anytime that medication was prescribed. Seems like obvious type of thing. The thing is that in the ER system, the patient record didn't always have a date of birth. Sometimes people get wheeled into the ER when they're unconscious. So we just sort of left that as null. But in the medication system, they had rules that said, well, you can't prescribe certain types of medication to people above or below a certain age. So in the patient record in that system, date of birth was required. So what do you do when you have a patient record in one system with a null date of birth that you need to put into another system that does not accept a null date of birth?
Make something up.
Right. So we'll use the SQL Server default, January 1st, 1900. Right? No, that doesn't make sense. Let's use the Unix default, January 1st, 1970. Right? I know, let's make it configurable. Right? And really, it doesn't matter what value we put in, we know that there's going to be a problem. But the thing is that it's not a problem when we're writing the code. It's not a problem when we're testing it. That's the problem with a lot of these types of semantic interoperability things. It's well, we don't know what to put in there. Rather than spending hours in meetings with business stakeholders, we'll just put in some value in the meantime and keep going. And then somebody forgets, and then it ends up going live. And then actual real people get affected when the system says, oh, I'm sorry, you can't prescribe that medication to the doctor. And the doctor says, what the hell? Why not? Because clearly this patient is over 60, and he's looking at a 5-year-old child. So these types of problems, sometimes it's as simple as a null value, that one system accepts null, another system doesn't, to understand, well, what does that null represent? What it does represent is the fact that the semantics of the two worlds are not aligned with each other. That's no longer a technical integration problem, that's a semantic integration problem. You need to bridge that gap. What we ended up doing in this specific project is that instead of passing around patients with dates of birth, we used what we made up, called an age range, where we had newborn, child, preteen, whatever, adult, senior. And even when someone was in the ER, we could know, okay, this is a child or this is an adult. And then all of the rules that existed in the medication system were then realigned around the age range rather than around a date of birth. Ultimately, what it meant is solving this integration problem was not just at the boundary. It involved going into each of the systems and changing their data models and in some cases their logic. When I say budget for it, understand when this thing blows up, and it will, it's often in production. So spend some time, whatever you want to call that, staging or usability testing or whatnot, or running the new version of the system alongside the old version. This kind of stuff will only pop up under real use of your business domain type of scenarios. And that when it happens, you may need to do some really big rewrites in order to solve those problems. It's not just oh, we need a small integration solution here around the edges. So budget for it. It's going to hit you anytime you're hooking systems together. All right. Now, of all of the slides that I've showed you so far, each of them has a solution to it. This is really the one side that I don't really have a solution for, in essence saying the technical integration is going to get worse before it gets better. We don't really have any control over that, but plus side, job security, right? And semantic interoperability, it's always been hard, it's always going to be hard. Just know that and take that into account when you're doing your planning. So the whole network is heterogeneous or homogeneous. You know, it's physics. It's a fact. You need to accept it, and you need to align a lot of what you're doing around those laws of physics. Otherwise, it ends up blowing your estimates and your projects out of the water. And in terms of the tech, just going back to that, anytime somebody says, and it'll work out of the box, that's a fancy way of them saying it won't work out of the box. All right? Almost nothing works out of the box. So not REST, not NoSQL, not .NET Java interop, not big data. Everything, what's that rule? I don't remember the name of it. It says, everything takes twice as long and 4 times as much as what you planned, even when you take this rule into account. So there's a name for that law. And that tends to be the scenario with any type of integration and interop, is it always ends up sort of growing arms and legs at the end.